The problem in discussion today is from the recent August Long challenge, and the problem name is special triplets. The difficulty level of this problem is easy, and its prerequisites are knowledge about divisors and some basic mathematics. So let us directly now read the problem statement. Let us read the problem statement. So Jintoki has been very lazy recently and he hasn't made enough money to pay the rent this month. So the old landlady has given him a problem to solve. Instead, if he can solve this problem, the rent will be waived. So let us see the problem. A triplet of integers a, b, c is considered to be special if it satisfies the following properties for a given integer n. So let us see. So the first condition is a mod b equal to c. Okay. So the next condition is b mod c equal to 0. And the third condition is that all three of these have to be between 1 and n. So let us now see the quick points that we derive from these three conditions. So from a mod b equal to c. So one thing is very clear over here, that b will always be greater than c, right? Since we are doing a mod operation over here, b will always be greater than c. What is the second thing? We know that c is a factor of b. So these are the two basic points that we gather from these three conditions. Now let us see a small example. So we have, say, n is equal to 3. So for n is equal to 3, let us try and find uh, all such triplets. So now if you see the minimum value of b, so min of b has to be at least equal to 2. So b cannot be 1, otherwise then c cannot have a value, because we know that b is greater than c. Therefore minimum value of b has to be 2. So for n is equal to 3, first let us try and fix the value of b and then find out the answers. So for fixed b, so b has just one factor over here, which is 1, right? So 2 has just one factor, which is 1. So the only value of c possible is 1. So now let us see. So for n is equal to 3, we have first 1 comma 2 comma 1, where a is 1, b is 2 and c is 1. Since a mod b will be 1. The next is 3 comma 2 comma 1, right? Because again 3 mod 2 equal to 1. The pair will be 1 comma 3 comma 1. So here again we have a is equal to 1, b is equal to 3 and c is equal to 1. So here again all of both of these conditions are satisfied, and therefore we get our answer that for n is equal to 3, we have a total of 3 tuples, right? So now we have seen a small example. Let us directly proceed to the solution approach. So first, before starting the solution approach, let us note down the facts that we already know, that b is greater than c, and we also know that c is a divisor of b. So first thing that we can do is we can fix the value of b, and then for that particular b, we can find all triplets where a and c are varying. So we can find all triplets a, b and c, and c is a factor of b. So what we can do is we can first pre-compute all divisors of all numbers, right? So this can be easily done in n log n. So this is not an issue. So first we will be pre-computing divisors of all numbers. Now let us see what we will do. So I will now explain this to you through example. So let us take n is equal to 13. Now starting, so the minimum value of b, so we saw that minimum value of b needs to be 2. So now let us fix b is equal to 2. So we have b is equal to 2 first. Now for b is equal to 2, let us try and divide 13 into segments of 2, distance or length 2. So 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10 and 10 to 12, and then we have n is equal to 13. So these are the 6 complete segments that we will have for b is equal to 2. Now, if you see what are the divisors of 2. So for 2, we have just one divisor, which is 1, right? So now it is easy to spot over here that for a mod b equal to c, we can just do for each multiple of b over here, we can just add c. So say mul of b plus c. So a will be equal to mul of b plus c. So if we do this, then we can ensure that a mod b will be equal to c, right? So what we do is over here, this is 1. So a will be equal to 1 and c will be equal to 1. So for a equal to 1, there is one valid pair. A equal to 3, we have another valid pair. A equal to 5, we have another valid pair. A equal to 7, we have another valid pair. So all of these pairs are, all of these triplets are for variable a, and b is equal to 2 and c is equal to 1. So for 7, we have another valid pair. For 9, again another valid pair. For 11, we have another valid pair. And for the remaining part, so this is just 1. So for 13, we have another valid pair. So if you check for b is equal to 2, we have 1, 2, 3, 4, 5, 6, 7. So we have 7 valid triplets for b is equal to 2. Now let us see for a bigger value of b, where it has more than one divisors. So maybe let us check for b is equal to say 6. Okay. So for b is equal to 6, now let us try and divide this segment into segments of size 6. So from 0 to 6, okay, and from 6 to 12. And here we have n is equal to 30. So this is just a half segment, or like a small part of the segment. Now over here, let us see what are the divisors of 6. So we have 3 divisors of 6, 3, 2 and 1. Now if you check in each of these segments, there will exist a value of a such that for each of these c, we have a valid a. So for c is equal to 1, only in this segment, what will be the value of a? Obviously it will be 1, because we said that what is a? A is a multiple of b plus c. So since multiple of b is 0, plus c will be 1. For c is equal to 2, a will be also equal to 2 in this segment. For c is equal to 3, a will also be equal to 3, right? Now going to the next segment, we have from 6 to 12, we again have for c is equal to 1, we have a equal to 7. For c is equal to 2, we have a equal to 8. For c is equal to 3, we have a equal to 9. So now there is one simple observation over here. So we can easily calculate the number of segments, right? So number of segments into number of divisors for a particular b. So this will give us the number of valid triplets. So this is equal to valid triplets for a particular b. And now there is just an edge case over here, that number of segments. So these are the 2 full segments, and we just have to check how many what is the number of valid triplets in the remaining range. That is so the size of this range, it will just be yeah, so the size of this range will just be n mod b, right? Because since b is equal to 6, so n mod b will be equal to 1. So we already know that the size of this range is 1. So we just have to check this separately. So it's not an issue. Now, so let us now just see a pseudocode so that we have finalized our approach. So let us see a quick pseudocode for this question. So the first step that we will do is that we will pre-compute all divisors of all numbers. So this is pretty easy. You can use the sieve concept, and we can do this in n log n time. Okay. Now, the next thing that we will do, that will iterate over b from 2 to n. As we know, the minimum value of b will be 2. So we will iterate over b from 2 to n, and for each b. So here we will be fixing the value of b. We will calculate the number of valid triplets. So now what are the valid triplets? It is just number of segments that will be created for every b into number of divisors of b. So this is just the number of valid triplets. And now as we discussed, the last segment that remains, which is not a full segment. So for the last segments, we can calculate triplets separately. So we will just check if say we have 1, 2, 3, 1, 2, 3 as divisors, right? As we saw for b is equal to 6. So, and we had from 12 to 13. We had the segment from 12 to 13. So over here, we will just check like so 12. So 12 plus divisor. So divisor of b. So first divisor of b. So is it less than or equal to n? If yes, then we will add it to our valid triplets, and if no, then just no, we won't add it. So this is the condition to check over here. So for last segment, we will calculate it separately, and yeah, this is the pseudocode. So I hope you have understood this. Now let us directly go to the implementation part. So starting the implementation, so first here I have initialized a vector of vector fact. So in this vector of vector, we will be storing all our divisors for each number. So here I have initiated a variable constant m. So this is the like maximum value of n over here. So for storing the divisors, what we do is we simply run two nested loops where I is equal to 1, I less than m, and I plus plus, and this inner loop. Now check this out carefully what I've done. For j is equal to 2 into I, j less than m, j plus equal to I. So here I is the factor of every number j. So this is a very standard algorithm, and this will run in n log n time. So here we have already calculated our all divisors. Now let us go to the main part. So here I've called the pre-process function. Now I've taken input t, number of test cases, and here I've taken input n, which is our boundary number n. Now over here for int answer equal to, I have initialized int answer equal to 0. So for I is equal to 2, I less than equal to n, I plus plus. So this I is nothing but the value of b. So we are fixing the value of b from 2 to n. So for each b, we will first calculate the number of factors. It is just fact I dot size. So fact I was this vector int. So fact I dot size is just the number of factors of b. Now what is x? X is the endpoint of the segment. So n minus n mod I. So I is b. So n minus n mod I is basically, so we saw for b is equal to 6, there were two segments from 0 to 6 and from 6 to 12. So basically x is equal to 12 over here, that I'm discarding the last small segment. Okay. So what is the importance of x over here? So after we get x, we can simply do x upon I, and then we can get the number of full segments that we have. So answer plus equal to x upon I into factors. So this is basically x upon I is the number of valid segments. So number of segments, and factors is the number of divisors. So answer plus equal to x upon I into factors. So now we will check the last segment. So the last segment I already told you, we can easily check it. So for j is equal to 0, j less than factors. So factors is the number of factors of this particular I, and j plus plus. So here we check that if x plus fact of I j is less than equal to n. Okay, so now this is pretty standard. So x is the largest integer divisible by b, which is less than n. So if x plus fact of ij is less than equal to n, therefore this is for checking what is the maximum possible valid value of a that we can set. So if it is less than equal to n, then just answer plus plus, and this is our full code, and here we will just output answer on a new line. So yeah, this will give you an AC, and I know there is an easier approach, but I felt this was easier to explain, so hence I went for this. So yeah, this is the end of the video, and let me know if you have any doubts, and thank you.